Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, we're going to take a look at radicals, which is a topic that frequently appears on both the arithmetic reasoning as well as the mathematics knowledge subtest of the Armed Services Vocational Aptitude Battery. As always, I strongly recommend that you work out as many of the practice problems as you see in this video as possible. That is, after I read a question, you should pause the video, attempt to work it out on your own, and then resume playing the video to see if you and I came up with the same answer. Again, on the ASVAB, you're not allowed to use a formula sheet or a calculator, so all the things we talk about in today's video, you're going to have to be able to do by hand, as well as memorize any formulas that I discuss. All that said, let's go ahead and get started with today's video. To start today's video, we need to briefly review some of the terms involving radicals, because as you'll see in just a few minutes, I'm going to use these terms as I work to solve some radical expressions. First, I want to point out that the square root symbol, which looks like this, is what's called the radical. The number inside the square root symbol, and we can use 81 in this case, as you can see, is referred to as the radicand. And this number that usually sits outside the radical, and we'll use 4 in this case, is referred to as the index. And this index tells you what operation to perform on the radicand. In general, radical expressions are written in this form, x to the m to the n. So if we look at this one I wrote over here more closely, we can see that the index is n, 81 is x, and in case it's not obvious, anything raised to the first power is just itself. So in this case, we can see m would be 1. Okay? Before we go any further, let me point this out. This is a chart that I recommend you learn at some point. And I went and learned this fourth column. That said, if you know the squares and cubes of the numbers 1 through 13, this should help you tremendously on the ASVAB. For example, you should know that 10 squared is 100 and 10 cubed is 1000. Again, on the ASVAB, time is very important. And by knowing these, you'll be able to save yourself a lot of time. And as a matter of fact, when I work through some questions in this video, I'm simply going to say that's one of the numbers on the chart. You should know it. Therefore, I'm not going to work it out fully. So just bear in mind that you should memorize these. Most of you probably know your squares, but it's a good idea to start learning some of the cubes as well, at least through 10. All right, so let's get back to our review. Okay, so in addition to knowing those basic terms that I mentioned, it's also important to realize that roots and exponents are related. And as a matter of fact, an exponent written in fractional form can be rewritten as a radical pretty easily. So as you can see, over here we have this a raised to the m over n power, which we can rewrite in radical form as a to the m to the n index. Okay, so let's take a look at an example of that using this example. So in this case, we have 125 raised to the 1/3 power. To rewrite this as a radical expression, again, it's going to look like this. We're going to have our root symbol, or radical. We know 125 is going to be the radicand. This 3 is going to be our index, and this 1 is going to be our power. And of course, as I mentioned, when it's raised to the first power, it's usually not expressed. So this is simply the cube root of 125. Okay, we're not going to solve that at this point. We just want to get practice taking something that's written with an exponential fraction and rewriting it in terms of a radical expression, which we just did right there. It's pretty simple. All right, so another concept that's going to help us simplify radical expressions is this. We can break down radicands into prime factors, And if we can break down a radicand such that it can be rewritten as an exponent raised to a number equal to its index, then the exponents will simply cancel out. So in this example, we want to find the fifth root of 32. Let's start by rewriting this as an exponent. Again, this power is 1 since it's not expressed. So this is simply the same as 32. Again, this goes in your numerator, 1, and the index goes in your denominator. Okay? Now that we've done that, let's try to find some prime factors of 32. Again, prime factors are numbers that are only divisible by 1 in themselves. So, for example, 2, 3, 5, and so on. So most obviously, I know 32 is 16 times 2. Again, that's to the 1/5 power. Again, I know 16 is 8 times 2. Again, we still have that 2 hanging out there. Again, this is to the 1/5 power. Again, 8 can be broken down into 4 times 2. And of course, we have these 2 times 2's hanging out over here. And then finally, we know 4 can be broken down into 2 times 2. And then we have 3 more 2's hanging out off to the side. As we can see, this is 2 times 2 times 2 times 2. That is, it's 2 to the 5th. Of course, this is raised to the 1/5 power. And so if we know our laws of exponents, we know that this becomes 2 to the 5/5, which is the same as 2 to the 1, or just 2. Okay? So we're going to use this idea, that is prime factorization of the radicand, to help us reduce or solve some of these radical expressions in this video. Okay, so in the event we can't break our radicand down into prime factors raised to an exponent that's equal to the index, then we have to know these radical laws in an effort to simplify our radical expressions. Again, the ASVAB is a very simple test that really tests your knowledge of math from basically 4th grade to 10th grade. Some of these radical laws come from Algebra 2, which most people don't take to 10th or 11th grade. So we only really need to know the first 2. We don't need to know these other 3. So let's go ahead and take a look at them. This first radical law says that if you have 2 numbers multiplied by each other to the nth index, you can split them apart into 2 separate radicals. So in this example, we have -8 times 27. We're trying to find the cube root of that. Of course, according to this law, we can take those 2 and break them apart as such. The cube root of 8 is -2, whereas the cube root of 27 is 3. So this becomes 2 times 3, or -6. So again, if you have 2 numbers to the index, you can break them apart into separate radicals. Similarly, if you have 2 numbers that are being divided inside the radical to the index, you can break them apart as well. So in this example, we have 16/81 to the 4th index. And as you can see, you can break those apart separately. The 4th root of 16 is 2, whereas the 4th root of 81 is 3. And that's another way you can simplify radical expressions. Okay, we're going to see a couple of examples of that as well. Bear in mind that, again, in the first radical law we looked at, there was multiplication inside the radical. If it's addition, you cannot use the law. If it's subtraction, you can't use the law as well. Okay, so just keep that in mind as well. All right, so let's take a look at an example in which we can use the laws of radicals to simplify a radical expression. For this example, we can see that we want to find the fourth root of 81 x to the eighth y to the fourth. So I'm going to write this off to the side as if I were working it out at home. Again, this is 81 x to the eighth y to the fourth. Of course, the index is 4. Again, according to the first radical law we looked at, we can break this apart into separate radicals since these are all multiplied by each other. That is, I can rewrite this like this. I can take the fourth root of 81 times the fourth root of x to the eighth times the fourth root of y to the fourth. Okay, so using that radical law, I took this and rewrote it like this. And now let's take these roots and express them as exponents, which we learned previously in this video. Again, in case it's not obvious, this is 81 to the first power. So this becomes 81 to the 1/4 times x to the 8/4. Again, this exponent goes to the numerator, whereas the index goes to the denominator, times y. Again, exponent, numerator, index, denominator. Okay? Some of these are pretty obvious to figure out. Again, we're going to deal with this 81 to the 1/4 in just a minute. But that said, we can figure out this one and this one pretty quickly. X to the 8/4. 8 divided by 4 is 2, so this is x squared times y. 4/4. 4 divided by 4 is just 1, so this is just y to the first, or just y. Okay? All right, so we're almost done. We just have to deal with this 81 to the 1/4. Again, we can use prime factorization in an effort to get rid of this exponent. So let's go ahead and try to do that. Again, we're going to try to find the prime factorization of 81. 81 is the same as 3 times 27. Again, this is to the 1/4. And we still have our x squared y hanging off to the side. Again, let's break this down even more. 27 is the same as 3 times 9. Again, this is x squared y. And as we know, 9 it can be written as 3 times 3. So this is 3 times 3 times 3 times 3 to the 1/4 x squared y. Again, this is 3 times 3 times 3 times 3, which is the same as 3 to the 4th. Again, raised to the 1/4 x squared y. This becomes 3 to the 4/4 x squared y. 4/4 is just 1, so this is 3 to the 1 x squared y. And again, anything to the 1 power is just itself, so this is 3x squared y. Okay? Again, it should be obvious that if you know your factors pretty well, you could have probably figured out that this would have been 3 to the 4th right away without having to do this work. So again, most people can go from here to here pretty quickly. But that said, I worked all this out in case you need to see the steps to solve this via prime factorization. Okay? And once we get to the other examples in this video, I am going to start skipping the steps because, again, I mentioned that chart that you should commit to memory, which will help you go from here to here and save you a lot of work, namely all these steps. So let's take a look at another example now. All right, so let's look at another example. In this case, we have the square root of 32 plus the square root of 200. Again, we're going to use our knowledge of the laws of radicals to help simplify this. But first, let me say this in case it's not obvious. This index isn't expressed, so we have to know that whenever the index isn't expressed, it's always going to be the square root. All right, so let's try to use the first law of radicals to simplify this. And that is, I'm going to rewrite 32 as 16 times 2. And then I'm going to rewrite 200 as 100 times 2. According to that first law of radicals, I can now break these apart. So this becomes the square root of 16 times the square root of 2 plus the square root of 100 times the square root of 2. Of course, we should realize that the square root of 16 is 4. So this is 4 square root 2. Again, 4 times square root 2 is the same thing. Plus, the square root of 100 is 10. So this becomes 10 times the square root of 2, which looks like that. Okay? And we can even take this a step further if we wanted to. We can factor out a square root of 2, which will leave us with 4 plus 10. Of course, 4 plus 10 is 14. So this becomes 14 square root 2. Okay, so again, it's important to know your squares and your cubes because right here you can go 16 square root is 4, 100 square root is 10. Okay, so that was that one. All right, so at this point, we're going to start some exercises. And again, I strongly encourage you to make an effort to work out these on your own. So for this first set of exercises, you can see that we want to express the following exponents as radical expressions. So let's go ahead and do that. We have 4 to the 2/3 power. And again, we're writing this as a radical. So this is going to be radical. This 4 is our radicand, so that's going to be the number inside the radical. This numerator is our power, so that goes there. And this denominator is our index, so that goes there. Okay? All right, for this second one, we have 25 to the 1/2 power. Let's go ahead and express this as a radical. Again, we're going to need a radical symbol. This 25 is the radicand, so that goes right there. This 1 is our power, and this denominator of 2 is our index, so that goes there. Again, more often than not, we don't express the 2 in a square root, and if something's raised to the first power, we don't have to express it as well. So this is simply the square root of 25. Again, we're not going to solve that. That's beyond the scope of this first set of exercises. So in this last example, we have 3 to the 4/5 power. Again, we're expressing this as a radical, so we need a radical symbol. 3 is our radicand. 4 is our power of the radicand. And 5 is the index. Okay, so that was it for these first exercises. Again, just going from exponents to radicals. All right, so let's do the opposite now. Let's express the radicals as exponential expressions. And for this first one, we have, let me rewrite that since my pen's starting to act up a little bit. We have the square root of 81. Again, in case it's not obvious, this is raised to the first power. And since it's not expressed, this has an index of 2. So let's go ahead and do this one. Again, 81 is our radicand, so that's going to be the integer in our exponential expression. This power goes into the numerator, and this index goes into the denominator. Okay, so there's that one. Let's go ahead and do this next one. All right, so we know our radicand is going to be the whole number or number in the exponent. Again, in case it's not obvious, this is the first power, and that goes in our numerator. This index goes in our denominator. Okay? And then finally, we have this one, 243 cubed 5th root. So this becomes 243. Again, this power goes in our numerator, and this index goes in our denominator. Okay, so that was it for this second set of exercises. Again, we're just practicing going from exponents to radicals and radicals to exponents. Again, that's important as you try to simplify more complex radical expressions, which we're going to see in just a second here. All right, number 3 says express the square root of the following numbers. So for this first one, we have x squared equals 49. Again, we can take the square root of both sides. This will cross out, leaving us with just x. Square root of 49, we should know from that chart, our previous math experience is 7. And again, in this next example, we have x squared equals this 144. Take the square root of both sides. This will cross out, leaving you with x equals the square root of 144 are just 12. Okay? All right, so let's combine our knowledge of everything we've discussed in this video to simplify these more complicated radical expressions. So for a, you can see we have the square root of 81m to the 64. All right, according to the first law of radicals, we can break this down like this. This will become square root of 81 times square root of m to the 64. We should realize right away that the square root of 81 is 9. So this is 9 times the square root of m to the 64. And again, in case it's not obvious, this has an index of 2. Again, square root is usually not expressed with an index. In an effort to solve this one, we can take it and express it as an exponent. And that's going to look like this. M to the, again, this power goes in our numerator, and this index goes in our denominator. So this is 9 times n to the 64 divided by 2, which is 32. And if we clean this up, this becomes 9m to the 32. Okay, so we simplified this first one. Again, whenever possible, you want to get a perfect square or a perfect cube, because as you can see, it saves you a tremendous amount of work. We went right from the square root of 81 to 9. Okay, so let's look at b now. We have the square root of 49, a to the 4th, b to the 16th. So using the first law of radical that we mentioned, we can go ahead and break this down accordingly. This is the square root of 49 times square root of a to the 4th times the square root of b to the 16th. Right away, we should realize that the square root of 49 is 7. It's a perfect square. All right, and that's going to be times the square root of a to the 4th times the square root of b to the 16th. In case it's not obvious, square roots all have an index of 2. More often than not, that index is not expressed. So as we did over here, we're going to rewrite these radicals into exponents so that we can reduce them quickly. So this is going to become 7 times, again, we're going to rewrite this as an exponent. So this is going to be a to the 4 over 2 times b. Again, this 16 is our numerator, and this index is our denominator. So let's go ahead and simplify this. This becomes 7 times a. 4 divided by 2 is 2 times b. 16 divided by 2 is 8. So this becomes 7 times a squared times b to the 8th, all cleaned up. Okay, so that was that one. Let's go ahead and look at C now, and I'm going to write it all the way over here so that I can have some room to work with it. Again, this is going to be the cube root of 9x to the 6th over 27. And for this one, we're going to have to use our knowledge of both laws of exponents to simplify this radical expression. First, we should realize that we can break down two terms under the same radical into separate terms like this. And this is the second law of radicals that we discussed. This becomes the cube root of 9x to the 6th over the cube root of 27. We should realize that the cube root of 27 is 3. Again, that was in the chart I mentioned, so this becomes over 3. And now we can use the first law of radicals to break apart this, numerator, and that will become cube root of 9 times the cube root of x to the 6th. Unfortunately, we can't rewrite 9 using prime factorization to cross out this index. So what we have to do is instead focus on what we have over here. So I'm not going to touch this cube root of 9. We're going to leave that as is. But that said, and again, we know the denominator is 3. That said, I'm going to rewrite this radical of the cube root of x to the 6th as an exponent, since I know that this will reduce. And this becomes x, again, power goes in our numerator, index goes in our denominator. So this becomes cube root of 9 times 6 divided by 3 is 2. So this is x squared over 3. And let's clean this up to make it look nicer. This is x squared cube root of 9 all over 3. Okay, and that is this radical expression simplified. All right, so let's clean this up so we can do the next 3 problems, and that will be it for today's video. And again, in light of the fact that you really need to practice a lot to get good at simplifying radical expressions, I may upload a video in which I just work on these types of problems. But that said, let's go ahead and move on to D. We can see we have this, 8 cube root of 5, and let me rewrite that since we're getting a little sloppy. For D, we have 8 cube root of 5 minus 3 cube root of 5. In this case, it should be obvious that we can factor out a cube root of 5, which will leave us with this, 8 minus 3. 8 minus 3, of course, is, and we're getting sloppy, 8 minus 3 is 5. So we can see that this simplifies to cube root of 5 times 5, which we can rewrite as this. 5 times the cube root of 5. And that is this one in simplest terms. Let's look at E now. E is probably one of the more challenging problems in this set of exercises. Okay, we have the cube root of 54 plus the cube root of 128. So the key to doing this one is to try to identify some cube roots of 54 and 128. As it happens, we can rewrite this one as the cube root of 27 times 2. Again, 27 times 2 is 54, plus the cube root of 64 times 2. And let's go ahead and use the first law of radicals to break this down even further. This becomes the cube root of 27 times the cube root of 2 plus the cube root of 64 times, again, the cube root of 2. Should be obvious that the cube root of 27 is going to be 3. So this is 3 times the cube root. Let me rewrite that. The cube root of 2 plus the cube root of 64 is 4, given that 4 times 4 times 4 is 64. So this is 4 times the cube root of 2. And now we could just add these together as if they were like terms. 4 plus 3 is 7. So this is 7 cube root 2. So this is completely simplified now. Okay, again, it's important to get good at trying to break down these larger whole numbers into perfect cubes and squares, because as you can see, I went straight from the cube root of 27 to 3 and the cube root of 64 to 4. Again, that's why I brought up that chart in the beginning of this video. All right, so let's take a look at the final exercise in this video. It's the square root of x to the 4th over the square root of y to the 5th. So with those in mind, let's write them off to the side. Again, this is the square root of x to the 4th, which is pretty easy to do, over the square root of y to the 5th, which we're going to have to make some adjustments to figure out pretty quickly. Again, in case it's not obvious, square roots have an index of 2, which is normally not expressed. All right, so the method I'm going to take to simplify this radical expression is to rewrite these radicals as exponents. So I'm going to do that for this first one. This is going to be x. 4 is our power, so it goes in the numerator, over our index of 2 in the denominator. So this one, as we can see, is quickly going to reduce to x squared. That said, if we do 5 over 2 in the denominator, it's not going to reduce evenly, so we're going to have to rewrite it such that it does. So again, I'm going to rewrite, and let me rewrite that radical symbol there. I'm going to rewrite this denominator as y to the 4th times y to the 1. Again, y to the 4th times y to the 1 is y to the 5th. And in light of that, I can use the first law of radicals to break these apart. So again, this is x to the 4 over 2 over, and again, we're going to use the first law of radicals to break these up. This is square root of y to the 4th times the square root of y to the 1st. And now we can rewrite this radical as an exponent, which will help us simplify it very quickly. And this is x to the 4 over 2 over, and let's rewrite this one as an exponent. That's going to be y to the 4 over 2 times y, the square root of y. Again, this is the square root of y. So now let's just clean this up. This is x to the 4 over 2, or just x squared, given that 4 divided by 2 is 2. This becomes y to the 4 over 2. 4 divided by 2 is 2, so this is y squared. And then since this is the square root of y, we can just write this times the square root of y. And just like that, this one is simplified. Okay, so again, we applied a few of the concepts we learned. We rewrote this numerator as an exponent right away. Then we broke down the denominator into two different radicals using the first law of exponents, which enabled us to simplify one of them very quickly. And just like that, we simplified it. So that's it for today's video. As I mentioned, you definitely want to commit this chart to memory. It will help you skip steps as you work with these radicals on the ASVAB. And similarly, I'm probably going to upload a video in which I just work on these radicals to give you more practice. That said, I hope you like the type of content I'm creating. If you do, please consider subscribing to my channel. In addition, you're more than welcome to leave some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose.
Konnichiwa.